Thank you, and welcome everyone to this 48 Academy about the request command. Request command is a relatively new command that we implemented a few months ago. The request command is meant to connect your script with an external source, so a external database or a service provider that provides some service to you. You might think that was already possible. We had the GETDATA command. That is correct. We had the GETDATA command, but the GETDATA command has some limitations, which I will not go into in this academy. And that limitations resulted in people using that GETDATA command to request some additions, and we solved that by making an entire new command, which is the request command, which has less limitations and at the same time I think is much easier to use than that GETDATA command. So that is the reason behind that request command. Very short reminder about Spring Academies that we are running. Simulate interviews we done 2 weeks ago. Recording is available. Reporting we done last week. Recording is available. Request is what we are doing now. Next week we will take a look at survey access, and then finally the week after on how to start interviews. Now, agenda of today. I will very shortly talk about what an API exactly is. The request commands connects to that external source by means of an API, and from some of the questions we have been having, seen that there is some confusion of what an API exactly is, and so we will take a short look at what an API exactly is. Then we'll have a demo. In a demo, I will also start with explaining a bit how an API works, and then we'll dive in how that exactly is implemented in Enfield. Then we will recap what has been handled in that demo. Talk shortly about error handling. Once you connect to an external resource, there is a chance that that connection goes wrong or that connection results in something that you did not expect. That needs to be handled. Talk shortly about that. Then I already told you this is the command that will replace the GETDATA command. So I will also talk shortly about how that will happen. And then, as always, we have time for some questions. So what that? Request, as I said, is used to connect with an API. Now, what is an API? An API is short for Application Program Interface, and an API is what is used to let 2 or more computer programs interact with each other. For instance, you can think if you as a human interact with a computer program, you use a user interface. If just 2 programs interact with each other without a human, they use an API. Example of an API is, for instance, our own API, the API, the Enfield API. We will take a short look at that later. A lot of people seem to know API only as the Enfield API, but that is just an example of an API. That is not the only API. Okay, but that said, let's do the demo. And as said, I will start this demo taking a short look at an API. And this one. I will be using our own API as an example. So let me maximize the screen. This is our own API. It's the help page of our own API that tells you all the so-called endpoints of our API. All these things, all these what is called URIs, these are the starting points of endpoints. Now, you look at this particular endpoint. This is the endpoint for KP addresses. You will see if I open this endpoint that it's just a URI. A URI is a special sort of URL. So this is what you would type in. And in a URI, you can have variables or not. In this case, we have two variables in this URI. One variable that tells you what particular survey ID this endpoint is aiming at, and one variable for the sample point ID, what particular sample point of this survey you want to get the addresses from. Now, if you then fire that, it will return in the body something like this, which simply tells you what the exact addresses, because that is what we are looking at, addresses of this sample point is. This format is called JSON. JSON is a key value format, so you have a key, for instance, the name, and then we have a value. In this example, that's a sample string 1. So this is a standard format, and this is the standard format in which most APIs communicate, and this is also the format that the request command supports. So that's it. One last thing to point out for those endpoints. All those endpoints also have what we call methods that you can use on that endpoint. Here you see them: get, post, delete. There are more. Those methods pretty much are pretty self-explanatory. Post gets information from an endpoint. Post posts information to that endpoint, and delete. There are more of these methods. Not every method can be used on any endpoint. The endpoint determines what methods can and cannot be used for that endpoint. So that's one example. That's more in abstract how an API works. Now before diving into Enfield, let's take a look at how that then would what actually happens if you then use such an endpoint. For that, I will be using a program called Postman. Postman is where you can test APIs. And, you can fire your own endpoint. You can run an endpoint and then see what that endpoint returns. That also will give us some sort of idea of how this works and what this does. Okay, let's wait until it actually has loaded. I do not want to update now. And there. Okay. I'm going to run two endpoints here, both again from our own for our own API. For the Enfield API, the first one will be where I perform a sign in our API. For this particular one, I not only send information through this URI, I also send information through the body, which is also in JSON format. I'm not going to show you what that precisely is, because that are my login credentials, so I don't want to expose them. But here it says in JSON format, the server, the domain I want to connect to, the username and the password of that username. Now, when I send that, it will return here a token, and that token I can then use to identify myself, to authenticate myself in other calls to the Enfield API. So we have our token. So that was a post command, as you can see. So let's run another one. This one is a get command, so it gets something from the Enfield server. In this particular case, it is the quota frame. As you can see here, we need one variable for that, which is the survey ID. It will get the quota frame for this survey ID. And I need one more thing for this. In the headers for this particular survey, in the header for this particular survey, I need, for this endpoint, I need to put my authentication key. That authentication key is valid, only limited valid. So I need to make sure this is only, I'm using the wrong one. Headers. Okay. Oh no. So this is the new authentication key I had. So let's do send. That request is sent, and now it returns in the body the actual quota frame of this survey. So this is just to show how API works, what sort of things you have in an API. You have a URI, you have a body, and there are headers. All three of them can be configured, and you will recognize this once we now step to the manager. When we start configuring an API, you will see that we are using all three eventually. So we can close Postman now. Let's go to Enfield. So if we want to use an API, we need to go to APIs, and we need to configure a API request. There are no requests at this moment, so I need to configure a new one. Let's first take a look at the API. We'll use 4 APIs in the demo. We'll start with a very easy one, and we'll make them progressively a bit more difficult. Let's start with a very easy one, and a very easy one is this particular API. So let me copy this one and this one. Copy. Let's see what it does, and we can see what it does by simply running it in a browser. And not twice. If I fire this one, it returns the IP address, and this is the IP address of the machine this API was fired on. So this is the IP. So this is my current IP address. So that's all that this API does. Okay, now let's configure this API as a request in the manager. So this is a new request. I need to do the URI here, which is what I showed you before. It has no variables whatsoever, so this is fine. I could choose different methods. Get is the one that should be used, and probably the only one that this URI accepts. So get is fine. It needs to have a name, and I will call it getter IP. Sure. Let me copy that name because I need that name later. So that is the name for this request. I can configure headers, but this request doesn't need any headers. And I can configure test values. But again, this doesn't need any test values either because there are no variables. So I can't do anything. I simply can save it. Go to that. I can send. request, and it will give me a IP address. If you paid attention, you will see that this is a different IP address than the IP address that was returned here. And that is because I have configured this on the Enfield manager. So this is actually running on the Enfield server. So this is the IP address of the Enfield server, not the IP address of my PC. This is the IP address of the Enfield server. So with that done, let's see how we then use this in a survey. Let's create a new survey. I will call this IP, or no, it's not this IP. I will call it Enfield IP address. It's an online survey. I need to upload the script. Now, let's first take a look at the script we will be using, which is this particular script. It's a pretty simple script. We load the Enfield Chicago template, and then here we have the request command. The request command has 3 arguments. Request result, which here is defined as a numeric variable. That is what it needs to be. In the request result, a number will be placed, and that number will tell you something about the result of this request, if it was successful or if it was not successful, and if it was not successful, why that was. More about that later. Then this IP address, that is a text var. This is what is returned in that body. So this holds a JSON string. This will hold the JSON string that was returned. And then finally, the name of the request that we did. And that was not this name, that was this name. This is the name we gave it. And then finally, I have a page where I simply display the JSON that was returned for this IP address. So let's save this. Get IP address, and then let's go back to this. We need to upload the script, and that was get IP address. It's valid. Nice. Publish it. Okay, start field work. And then we can copy the live link. Let's see what we have. And there it is. It has run the IP and it has returned the IP address of the Enfield server, mainly this IP address. Okay. This is a pretty simple. This is a pretty simple API. As a matter of fact, this is the sort of API that you could even run as a template theme, because it doesn't require anything. But for now, we will run it on the server. So let's build on this one. We have the IP address. We would like to know some details on this IP address. Where is this IP address exactly? There's an API for that as well. And that API is here. That is this particular API. And that, as you can see, requires a variable, namely the IP address where you want to get the details from. So let's configure this one as well. Let's go back to our server. So let's end this one. Back to the server, back to the APIs, and surveys APIs. And we'll get a new request. And that new request, the URI of that new request is this one. So we have this IP address, which is the variable that will hold the IP address. We need to give this a name as well. So we'll say this get IP details. Let's remember this one as well. Save it. This one doesn't have any headers either, so we don't need to add any headers. It has test values, and mainly this IP address, so we can add a test value. We can add a test value for this IP address, and then we need to add a value. I suppose let's take the value of the IP address that was returned when I run it on my laptop. Let's copy that one. Let's put that here. And now we can again run a test. So let's run a test. And you will see that actually says that this is not a valid IP address. So I did something wrong here. Let me do it again. Okay. Looks pretty much the same, does it? Send. Okay. Let's not worry about it. Now, let's save this. And let's actually run this in the manager, and we will see what it says about the Enfield server. So we need to create a new survey. So let's create a new survey. Let's call this time IP details Enfield server. And this is an online survey. Let's create it. Need to upload the script, so let's take a look at the script that we will be using for this one. That is this script, get IP details. Now, this fires the request to get the again this IP address for the Enfield survey. This is not the name of that survey, so let's make sure that we use the correct name, which we can get from here. That was getter IP. That was the name we gave it, so let's make sure it has that name. And then it returns that in a JSON string. That's not nice to show, so we parse that JSON string. For that, we have created a new operator, which is question mark JSON. And that then simply says loads the JSON string. So this is the JSON string. It needs to be a valid JSON string. And then you simply say, get me the value of this key. There's only one key in this JSON string, which is the IP. And then it gets the value of this particular IP. Then we run a new request, and that request then actually gets the details of that API request. And then we first we display that JSON string that is returned. Then we parse that JSON string also by finally end up with a page where we nicely formatted the information. So that's it. One thing that we still need to do, we need to make sure that this name is actually the name that we configured on the survey. So let's check that. Let's go back, APIs, get API details. That was the name that we used. Copy. And let's go back here. Actually, give it that name, get API details, save this, get API details AP. Back to the survey, go to surveys, go to the survey we created, set up, upload the script, get API details AP, open, save it. And publish it. Start the field work. Copy the live link and let's run it. And here you see it actually, the Enfield server actually returns a valid IP address. Kantar server, Kantar firewall does not seem to do that. But the Enfield server does that, and as you can see, these are the details that as returned. This is actually the Enfield server in the Americas, so it returns the details of the American Enfield server, which seems to be in Ashburn, Virginia. And the next step is then where we use the JSON expression to format this nicely into a sentence. Location IP server Ashburn, Virginia, US. So that's one. One last thing to do here before we continue. This was the IP address of the America server. I could also run the same. I have the same setup in our Asia Pacific server. Let's run that one again. So just to make very sure that we are. So this is the address of our American Pacific server, because this one is running in Asia Pacific. It's in Hong Kong, the same. So I could do the same for the European server, but I'm sure you believe this by now. So these are two relatively simple APIs. One that only fetches the IP address for the machine that was fired on, and then the other one that takes the that takes that IP address and gather the details of that IP address. Let's make this slightly more complicated. For that, I will leave the American server and I will go to my European test server, where I have slightly more things set up. Okay, so let's go to the APIs here. After my server list. So the APIs we'll take a deeper look at are these two. Let's start with this one. Let's simply look at how this API is. It's an API that gets the current weather details of a city, any city in the world. The API needs a authentication key. For this particular API, that key needs to be added to the URI, which is done here. We have one variable which is city, and this will return then the current weather for this particular city. Again, we have no headers. We have one test value. For city, I already filled in a test value. So let's send this one and let's see what it returns. Now, it returns something slightly more complicated because it returns a very large JSON string. This is our first complication here. As you can see, the city name it has returned here, it's not very current, but anyway, it returns some weather information. So let's use this in the script. Let's actually take a look at the script that I prepared for this, which is this one. Let's look at the script and let's make sure that we have the JSON underneath it. So we have one question here where we actually ask for which city would you like to know the weather. We save that in city, which is the variable that we use in our string here, which is city. Note, this is a comment variable. It does not need to be a simple data. It's any ODIT variable will do. And then we fire the request. We note the request result. We store this JSON string in weather, and this is the name of the API, city weather, city weather. And we get the result, and because this is a bit more of a complicated JSON string, our JSON expression is a bit more complicated. First, we want to get the temperature, the temperature, which is this one. And as you can see, this is in what we call a array, to be recognized by the square brackets here. So this is the first array returned, also the only one. You do that in JSON data square bracket 0, which means the first array object of this data, and then the same thing, point city data source and a point app temp, and that will then return the temperature, which is 10. Okay, we do that for all here, and then we have one more slightly complication where we do here the description, because that one is here. Weather, again, this is still in the array, so we do data square bracket 0, that we get the first array. Then we want the weather key, and then this is not an array, this is just a stacking of new key value pairs. So we simply then want the value for description, which currently is few clouds, and we put that in description. Then I do something else here, which I will not talk about now. Let's first run this. No, let's first actually do one more thing. Let's see what happens if I actually fill in a unvalid city name. So let's send this one. And as you can see, if I fill in an unvalid city name, it actually returns empty values. That is I had hoped it would actually return an error, but this one doesn't. It just returns empty values. Let's remember that this is what it does if we fill in a wrong city name. And for now, we're done with this. Let's actually take a look at the survey. Let's run the survey. So survey, I already prepared this survey. It should be a list. Load the list. Favorite ones, these are the two surveys that we are going to use. So the first one is city weather, which is the one that has already the script loaded that I showed you, so we can immediately copy the live link, run this script, and then it will ask me for which city do you want to know the details. Let's again say Rotterdam, and then it gets the JSON string, it formats the JSON string into a nice sentence. The weather for Rotterdam on this particular date for this time was 10 degrees, scattered clouds, dry. So just to make sure that this is not running, we could fill in another city. Try this one. And then we get the weather for Berlin in Germany, slightly different temperature, pretty much the same weather as in Rotterdam. So this is one. Now we already said what happened. We already saw that if you type in the wrong name, that it actually returns empty values. Now that is an error handling that I implemented here. I check if the city name is empty, because if it returns empty values, that city name that is filled here will be empty as well. And if that is empty, I simply say that city is not known, try again, and I send people back to the first question where they can try to gather the correct name. So let's take a look at that as well. So let's go to sample. Let's run the survey again. Now let's make sure the city is not known. So we are sent back, try again. And if we then do the correct city, that will actually return the correct information. So this is one way of handling these errors. Normally, what you would get back, I actually wanted to get to the script. In the request result, you will get a indication of the if your call was successful. 1 means successful. There are several other values, which means non-successful. We will take a look later what those values exactly are. In this particular case, it actually returned 1. But as you can see, we did not gather any useful information. So make sure if you run APIs that you test them and that you do not rely on the fact that if it returns 1, that the information that it returns is actually what you expect. Make sure that you check that the information you get back is actually what you expect. And if it is not, you need to decide what to do. If you want to end the survey because you really need that information, or if you want to try again. We'll have slightly more to say about error handling lately. This is it for now. Now, this particular error happens because we let people type in city names. We could also try to get a city name from a list so people don't have to type it in, and we actually know that the city that they are using exists and should warrant a result. For that, we need a list, preferably a list of all cities in the world, which is a bit much to have as a list in your Odin language. Luckily, there is an API for this. And that is the next API we'll take a look at, and the last API. So let's go to, can close this one. Let's go to the manager again. And back to surveys, to the API. And as you probably already guessed, this cities in countries is the API we're after. This API takes, in this particular instance, 2 variables. One is the actual country, which is the country abbreviation. So for the United States, it's US. Then it gives a list of all the cities in that country. That was a way too big list. For some countries, it returned 10,000 of cities. So that is way too big a list to handle in Enfield. So I needed a way to minimize that list. You could do that by actually creating an API in between here that handles that result, but that seemed a bit much. So I actually looked within that API if I could filter even more deeply, and that was possible by using the population. This says I want cities and this, but at least this amount of population in it, and that then is this second variable. So that's this URI. This one actually has a header, because as you might guess, this is the sort of API where you need to identify yourself for. This has a static API key. So I place these API keys in the header, which is where they should be. The header only accepts static information because headers typically have these sort of authentication in it, and we only accept static information there. You cannot fill in a variable through the script. That would be very unsecure, because then you would actually expose these values to the outside world. So that's about the headers. test value. Test value I'm using is Great Britain with at least 500,000 population, which is also the limit that I placed in the script, but more about that when we look in the script. So let's send this, and it returns, as it says, 7 cities that match our criteria in Great Britain, at least 500,000 populations, and it returns them in an array, and this time we have 7 items in that array. So this is 0, this is 1, this is 2, this is 3, etc. And then here in name, we have the actual name of the city. So this is what we will be using in the script. So let's take a look at our final script. And that is big city weather. So we start with asking, please type in a country code to fetch the list of cities from that country. Then we still are relying on people typing in a correct country code. But this is actually, if I could fill in a list, because this is a handleable list, this is a list of slightly over 200 countries. I didn't do that because, yeah, for this demo, this is good enough. Well, you type in a country code, then I put the population at 500,000, which is the minimum that I want, because that more or less returns a workable amount of cities for most countries. And I explicitly ask what is the minimum population you want, but the minimum that you have to fill in there is at least 500,000. And then it fires the request. It gets that result in the object city list. I check what the total numbers of cities are that are returned. If it is more than 10, I loop in. I say simply say there are too many cities. Please go back to the minimum population and raise that population until we have no more than 10 cities. I do that because I need to create a list of these cities. And to do that, I need that put command here, which then cycles through all those arrays. And I don't want to do that endlessly. So I limit it to 10. And this will get me a list. This will get me a array, a 10 array, each slot holding a city name. I run a repeat to get basically to get this control to make sure that I only here show codes that actually have a value. Because otherwise, if, for instance, this returns 7 cities, it will show 3 empty ones. And now by having this code here and actually making this control, I make sure that I only show 7. So you pick the city, and then, well, it does what we saw in the previous one. It simply runs the city weather request for that particular city. Error handling I did in this one, if the city actually doesn't exist, or if it doesn't know that city, I simply end the survey this time with a special code, so I know that it has ended because the city weather request did not recognize the city. Because remember, this is a different API than this one, so it might very well be possible that somewhere in the translations, the first API returns a city which is differently translated here and is not recognized by this. So this is still an error that I need to handle here. And then finally, we display this. We display the weather. So with that all being explained, let's run it. Survey. Only the favorites. And this is big city through API. Setup. Let's get the live link. And let's run this one. Type in a country code. Well, let's start with France. Type in the minimal amount of population. Let's do 500,000. Next, and for France, that actually returns no more than 10 cities. So 3. Let's get the weather for Paris. And then it returns me the weather for Paris, which is actually cooler than Rotterdam, which is notable. Okay, let's do one more. Let's actually see what happens if more are returns. This is India. So if I again do 500,000, it will probably tell me, yeah, there are too many. There are more than 10 cities in India with more than 500,000. So pick a higher number. Let's do 1 million. Still too many cities with more than 1 million inhabitants. So as you see, we raised the minimum now to 1 million. Let's do 2 million. Still too many cities with 2 million people. Let's do 3 million. And that actually returns less than 10 cities. Now let's get the weather for Hyderabad. Next. And the weather in Hyderabad. Quite hot. Okay. That is the end of the demo. So let's return to our presentation. Any questions at this point, Art? You are very distant.
Yeah. No, that should be better. Yeah, the first one was a comment about where the first demo went wrong. A parameter name was changed. I think, yeah, I'm always happy that we have these live demos, but of course, doing it all live, it may cause, yeah, some errors, of course, to occur. So I hope the people understand that. The first question, in your example, the return data is in JSON format. Can it be processed if it's not in JSON format?
And not through that JSON object, no. Default, we handle JSON.
Okay, good. There was also another question about the examples. Yeah, they found they were very useful examples, and if we will share the scripts after the session.
The 2 first ones, so the simple ones, are actually part of the documentation. So you can find these 2 in the documentations. The 2 other ones rely heavily on you having the key to authenticate yourself in that to that API. And we cannot share those keys. So yeah, it doesn't make much sense to share those scripts because you can't use them anyway because you don't have a key for those APIs. You can create those keys yourself, but then you can also set them up yourself. Yeah, no, we will not be sharing the more complicated ones because yeah, you can't play with them either because you cannot access those APIs without those keys. Any other questions?
Clear. No, a final comment from me. Yeah, apart from what you have been explaining today about the API, also note that if you go to the NIPO website, you will also find a lot of articles about the principles of the API and some examples on how to use this, our API in the Enfield Manager as well. So yeah, if you want further information, take a look there as well. And that's all, Frank.
Okay, cool. Now, let's recap. So we have the new request command. Takes 3 parameters: request result, which is a number indicating the result of the API call, request return, which is the data returned by the API, request name, the name configured in the Enfield Manager. There's a new operator, that's $JSON, that takes a JSON string and then the value name, and that will return the value of that key. Variables can be passed to the API if they are configured in the request object using the curly brackets, that is something that will be recognized by everyone that is used to configuring exit links, because that is using the same thing. It's using the curly brackets to replace variables from the script. Variables cannot be passed through the header. I already explained that is for security reasons. You can pass variables in the URI, you can pass variables in the body, not in the header. One thing important to realize, if you pause an interview and then you resume that interview, the requests are handled as was. So the request will not be run again, which is standard. That is how all commands are handled in a resume. With one very noticeable exception: if you change that request object, and it doesn't matter what you change in that request object, if you change something, which basically means if you saved it, if you have made a change that requires a save, then that request will be run again if you resume that interview. So keep that in the back of your mind when you start editing request commands. If that request is actually used in a script and that script has paused interviews, that might actually mess up the resumes in that script. So keep that in the back of your mind. Modified request will be run as is, which is basically what I explained before. Error handling. As I said, the first variable that is returned is a result code. We return a few different ones. One is the success status code. So that is the one that you should always check. Do not assume that if that is a 1, as you saw in the city weather API, that means that the data that is returned is actually useful. It might still be that there is another problem which results in you not getting useful data. So still check if the data is useful as well, but at least check if the status code has been returned successful. And then we have a few details on why those API call was failed or not. What we expect you to do for each call, we expect you to handle these errors. If you don't, and once you start analyzing your data, you see that there are gaps in your data because sometimes the API simply did not return data or did not return the data that you expected. And you have not handled these codes. You have not handled these errors in your script. We will not start looking what went wrong. If you go to the help desk and you issue a case there, we will close that case. Because if you haven't handled these errors, we simply don't know where to look. So that is pretty important. Please handle these errors in your script. Finally, GETDATA command. As I said, request is the replacement of the GETDATA command. That means that GETDATA will be retired. We already started that process. As of now, you cannot create new GETDATA configurations anymore, which means you can only use the ones that are already configured. As of now, if you upload a script and that uses a GETDATA command, you will get a warning telling you that this command will be retired. Pretty soon, somewhere in the summer, that GETDATA command in your script will actually become an error, which means that you can no longer upload new scripts that use GETDATA commands. You can only then use the scripts that you already have uploaded that use GETDATA. And in the second half of this year, we will actually remove the configurations, which means that the GETDATA command, even those that are already uploaded, will stop working altogether. So make sure if you use GETDATA that you change them all into request commands. Any last questions, Art?
No, these were all the questions.
Okay, perfect then. The final remarks. A recording of the session will be available later this week. Manuals are already updated. And as I said, they hold in those manuals, you can find the two first examples that I shared with you. The NIPA and ODE, the NIPA ODE developer makes sure that you use 5.18.0.26. Earlier ones might not recognize that request command and report it as an error. If you have any suggestions for a new topic of an academy, please write to your help desk and we will take that into consideration. Next week, we will have the next academy about survey access. So that was all for today. Thank you for your attention and talk to you next week. Bye-bye.
Thank you all for joining. Bye-bye.